In the seventh question, we have x times sine inverse x. Okay, there's an inverse function and there's algebraic function. So, you know what to do. Integral of u v u, or you can say integral of, since this is u v rule, let's write u times v only. So, integral of u times v dx is equal to u times integral v dx dx. This is what you have, right? Okay, and in this particular function, do you observe that integral of x sine inverse x dx for I equals this? Do you observe that this is more complicated and this is simpler? This will be v and this will be u. U, which is sine inverse x, will remain as it is. Integral of x is x square by 2 minus integral of derivative of sine inverse x is what we are interested in. Derivative of sine inverse x is 1 upon root 1 minus x square. Okay, and integral of x, which is x square by 2 plus constant, is what I'll be getting, right? Now integrating this may be slightly long, and let's see where does that take us. So x square by 2 sine inverse x. Before this, we have learned partial fractions, we have learned algebraic expressions and integrals. And let's see where does that take us. So this is minus 1 by 2 integral of x square root 1 minus x square. This is what you get. Okay, so what next? This has been integrated, but what about the integral of this? Now this will create a lot of problems. Had there been a linear at the top, this is one form which we have already seen. But this x square upon root 1 minus x square will be difficult. Now what will you do in this case is, you can write this x square as 1 minus x square with a minus. Okay, this becomes x square minus 1 will be taken care of by this plus 1, and there's a root of 1 minus x square. This converts to what? This converts to minus 1 upon root 1 minus x square. Okay, that's pretty simple. That is easy to integrate. Plus 1 upon, just a minute. This is minus of 1 minus x square, right? This is what you have. Not 1. This is 1 minus x square over there. 1 upon root 1 minus x square. And yes, this is sine inverse x, but what about this? This converts to minus of root 1 minus x square plus 1 upon root 1 minus x square. And do we know the integral of this one, which is sine inverse x. That's not difficult. But what about the integral of this one? Now, this particular thing, by the way, can be found easily, but this is exercise 7.6, right? And such kinds of expressions which are of the form under root of a square minus x square dx. The integral of this has not been covered up till now actually, and this will be covered in the next exercise. As you can see over in the NCERT, in the next exercise this will be covered. I'll give you the formula over here first of all, and then I'll give you another method of handling this. By the way, when you encounter this question in general, you'll use this method and then this formula only, using this approach, right? Therefore, I've solved with this approach, but then I'll give you another method for this exercise, specifically for this exercise 7.6. If you don't know this formula, then what will you do? So for that, let's continue further, and the formula of this, what will this be? Okay, this is x by 2 under root of a square minus x square. Mind you, I'm directly giving the formula over here, which will be covered in the next exercise. This minus a square, plus a square by 2 under root of a square minus x square plus constant is what you'll need. Under root of, this is not this, this is sine inverse x over here. This is what you'll have. So under root of a square minus x square dx is x by 2 under root of a square minus x square plus a square by 2 sine inverse x plus c is what you'll get. And this expression is equal to this, which is equal to this plus this. This can be integrated with this plus this is sine inverse x directly, right? That's the approach that you can follow and get the answer. But then for exercise, from the point of view of exercise 7.6, what will we do? So for that, there's another idea, right? Let's get rid of this whole thing and then solve it using another approach. What is the other approach? So I, which is equal to integral of x sine inverse x dx. Such kinds of questions can be tackled with a substitution first. What's our substitution? The sine inverse x is a problem creating thing, right? So can I take sine inverse x as some new variable, right? Can I replace sine inverse x by theta? That tells me, okay, x will be equal to sine theta and dx will be equal to cos theta times d theta. Yes or no? Yes. Therefore, I will be equal to integral of x, which is sine theta, sine inverse x, which is theta, dx, which is cos theta, d theta. Oh, now it becomes algebraic and trigonometric, right? Yes. Integral of theta times sine theta cos theta is sine 2 theta by 2. So there is a 1 by 2 outside d theta. Now this is algebraic and trigonometric. This function can be taken as v and this here can be taken as u, and now I can apply by parts. Once again by parts. So therefore I will be equal to 1 by 2 in the bracket, right? 1 by 2 is outside. So in the bracket first function, which is theta, times integral of sine 2 theta, which is minus cos 2 theta by 2. This is the integral of sine 2 theta. This is what you'll have, right? Minus integral of derivative of this first function, which is 1, integral of the second function, which is minus cos 2 theta by 2 d theta is what I'll get. Right or not? This is what I'll get. Half is okay, this goes inside, this becomes minus theta by 2 cos 2 theta. Okay, that's one thing. And what is this? Half goes over here. Half is already over here. 1 by 4 minus minus will become plus. Plus 1 by 4 integral of cos 2 theta d theta is what I'm getting over here. This further becomes equal to minus theta by 2 cos 2 theta. Cos 2 theta, the integral is sine 2 theta by 2. So this becomes 1 by 8 sine 2 theta plus constant. But is this the final answer? No. We'll have to replace every theta in terms of x. Okay. And we know that theta is equal to sine inverse x. This is okay. What about cos 2 theta? In terms of sine theta, if I am able to write that, then it becomes simple, right? So this is minus theta by 2. Cos 2 theta in terms of sine theta. You have to write in terms of sine theta so that I can replace it with x, right? Cos 2 theta is equal to, you remember, this is equal to 1 minus 2 sine square theta plus 1 by 8. What is sine 2 theta equal to? Sine 2 theta is equal to 2 sine theta times cos theta. And what is cos theta equal to? In terms of sine theta, you know that cos theta is equal to 1 minus sine square theta in the under root. So I'll write it as, okay, you can write it as cos theta only plus a constant of integration. So we began with this theta times sine 2 theta, and you have taken first function as u, second function, this first function u, second function sine 2 theta, which is easy to integrate. Theta remains as it is, integral of sine 2 theta, then minus, this is also okay, you have integrated this, then you have multiplied this. Okay, this becomes 1 by 4, this also becomes 1 by 4, take care of that. This is 4 over here, yes. This is supposed to be 4, this is not 2. And similarly, this is also 4, this is also 4, right? Take care of that. And what else? Is there any other error? Please check that. Cos 2 theta integral will be sine 2 theta by 2. So this becomes a 4. And now this becomes a 4, this is a 4, right? And after this, we have to replace theta with x. So let's do it. Theta in terms of x will be equal to what? So you have minus 1 by 4. Okay, let's keep that 1 by 4 separate. Take this minus inside. This becomes 2 sine square theta minus 1, which is 2 x square minus 1. What about this theta? This theta is equal to sine inverse x. Can you observe that? This is sine inverse x. And what else? This is 1 by 4 sine theta is x. And this cos theta, what is cos theta equal to? Cos theta is equal to 1 minus sine square theta in the under root, which is 1 minus x square in the under root, plus constant. And that is my required answer for this question using this approach over here. Okay, this approach involved initial substitution of this sine square theta, sine inverse x equal to theta. What else after that? There was another approach which we discussed in between in the initial stages, and that approach involved that extra formula which will be discussed in an exercise, right? But in general, such kind of questions involving algebraic and inverse functions, for such kinds of things, you will take integral of x and derivative of sine inverse x, right? So first function will be this, second function will be this, for which integral is simple in that approach, in the previous approach that we saw, right, in the initial stages. And for that, you'll need one more formula, which is under root of a square minus x square in general. I think that's pretty simple. This is also simple, that is also simple, and you should be aware of both the approaches over here. That's the complete solution and the final answer of this question over here.